I have to share my screen first. Sharing. Yeah, I see the I saw the video. I saw the camera. I can see the screen is already on it. So I cannot hear you, Xiaoyu. s- uh, Please give me a signal when you when we're ready to start.
Okay.
Okay.
So, welcome everybody for our Scientists with Wings series seminars. Today it's our honor to have Dr. Carl Gu from the University of South Australia. And his topic today is airport infrastructure requirements and planning challenges to enable hydrogen-powered aircrafts. And of course, at the Griffith University, the university acknowledged the people who are the traditional custodians of the land and pays respect to the elder, past and present, and extends that respect to other Aboriginal and the Torres Strait Islander people. So, as usual, this is going to be recorded for the presentation, but the question and answer. So how can I turn off that? How can we set it up separately?
Is there unlinked?
So it says unlinked, yeah.
No, you're coming through the speakers in the other.
Yeah.
Oh,
I can almost hear it just a bit behind what I'm saying.
yeah. But
Do you need the microphone? I mean, do you need all the microphones?
I don't need the microphone, but they are going to, if they are using the team, they speak. Can you hear us?
Oh, it's on Teams. You're right.
Yeah. I think it's already. Did you need to unlink over there?
Yeah, I've looked. It's not linked over there either. It must be something. Maybe if you look at the audio, see if anything that.
I can turn off these two.
Testing?
No. Yeah.
Maybe try turn off the program. Oh, that I don't know. That'll affect the Teams. And maybe turn on one of the other ones.
Then turn it off, and then we won't be able to
hear them.
But I can do this. I can use this one.
Turn these off. You don't need it.
No, because I was trying to see if they're going to be. Yeah. So, Carl, can you say something?
Yeah.
Okay,
Can you hear
I just move this and to over there. Okay. Oh, it's all right. It's
Oh, it's
the
not
university's
actually,
problems.
actually,
Yeah. We need to file a complaint together. Okay. So this is recorded for the purpose, and because somehow these rooms are unable to unlink with each other, I'll just put the speaker over here, and you can see the PowerPoint over there. Okay, it's all yours.
Okay, thank you, Xiaoyu. And so, yeah, thank you for it would be honors to present in the seminar. And today I'm gonna present the current research just done by research team from UniSA Ashley Griffin, I think team right here. I can see him, and also the Mary Johnson from Purdue University. We're both interested in sustainability and sustainable aviation fuel. And we can see, you know, in the future, if we want to achieve the carbon zero carbon emission, so sustainability, sorry, sustainable aviation fuel can play a big role in that process. So my personal interest in actually the airport sustainability and operational management, and when I see the topic about the hydrogen fly, I directly just link to my field. Okay, if we want to provide we want to support a hydrogen powered aircraft, a hydrogen powered operation at the airport. So what should the airport do, you know, and to support them? So this is the why we conduct this research, and so let me talk about what we can the content of today. First, I'm going to discuss some background, and I believe all of you have all from aviation field, so I won't talk too much about background. And then we can talk about I can talk about the research question methodology, and then the funding. The background actually the currently the environmental challenge is high on agenda, and all around the world they talk about climate changes. So we have under a very high pressure to reduce our carbon the action footprint across the different sectors, include aviation. Although we only contribute around 2% of the human-made carbon emission, but you know we release the carbon emission and a very high altitude of the atmosphere, which means the carbon emission will maintain for 100 years over there. So the organizations such as Air Transportation Action Group, which are part of ICAO, I believe, and other group like organization like IATA has set up a goal for global aviation industry to reduce the carbon emission by 50% by 2050 relative to 2005 levels. Also, countries such as Australia and Americans, China, and Europe countries, they all have their you know their own goal to reduce carbon emission and achieve the natural, what we call it kind of net zero carbon emission, or the natural carbon emission, probably around 2050. Um, so the industry around world, different industry, include aviation, have different strategy to reduce the carbon emission. One is to use the sustainable alternative fuel or aviation fuel. And I remember if you, according to the goal set up by IATA, IATA and ICAO. So to achieve that, achieve the goal, SAF, which is the Sustainable Aviation Fuel, gonna contribute to 23 to 30 something, 30% of the contribution. Okay, and so aircraft manufacturer like Airbus, Boeing, and some small small aircraft company like Universal, Hydrogen, Lufthansa, and in Australia is called Stretchak. I have that in the next strand. Yeah, Skytrain the airline, and I have the what's the manufacturer name? I just cannot remember at the time. So they are focusing on the produce the smaller aircraft, regional aircraft, and when I explore a lot of information, and found a lot of research regarding hydrogen aircraft and the technology to, how to apply the hydrogen on the power plant. There are rare and limited study focused on what the airport should do. So the goal of this paper is to investigate the research to investigate the requirement for airports to enable the hydrogen flight, and if we want to achieve that in the near term, what the airport should do on their planning process. There's some more background of the relative information. The hydrogen, as one type of sustainable alternative fuel, probably it is the best alternative fuel for aircraft for achieve the decarbonization. If you compare the efficiency to the environmental friendly. However, those hydrogen have to be have generated by using renewable energy. Okay, it doesn't make sense if you use a coal to produce the electricity and then produce the hydrogen, right? So the hydrogen have a very strong power, energy power. I mean energy density. However, the liquid hydrogen, the volumetric density of the liquid hydrogen is lower than the traditional jet fuel. That means the hydrogen powered aircraft need to be longer and heavier fuel tanks. And I read many report, and they estimate the hydrogen aircraft will be 5 to 10 meters longer than the traditional design. So, and the hydrogen powered aircraft is expected to be commercialized in the next 5 to 15 years. The first, as I know, is the Skytrans airline in Queensland. You probably already know that, to plan to have the first Australian hydrogen fly in 2026. And that aircraft would be hydrogen electronic aircraft, which means use a hydrogen. Okay, we're back.
Okay.
Can you hear me?
Yeah.
Okay, cool.
Was it right?
So to support hydrogen operation, the airport definitely to need upgraded infrastructure because the regulation change and the larger aircraft, right? So I'm curious, what's the readiness of the airport to for the hydrogen operation? So we investigated the published document of 7 major Australian airports that is designated by CASA, which are 7 major international airports. So we figured out they have no established plan for the hydrogen application, not just the hydrogen aircraft or hydrogen aircraft operation. So they even do not have any plan to use hydrogen around the airport. However, they do have a sustainable or environmental related plan, or they have the sustainability report or plans. So those plans are both of them mentioned they want to reduce the impact on the environment and reduce their impact on climate changes. To use the, for example, to use the renewable power, renewable energy, or they want to reduce the usage, the emission, carbon emissions. So they both have the goal. However, they didn't relate it to their planning on using the hydrogen or to support the hydrogen operation. So here is create a gap between their target and the actually how to achieve them. That is the meaning that the why we conduct this research. Okay, there is some actually this is the report. This is a picture from the report from Boyin and Castillo. The Commonwealth Scientific and Industrial Research Organization is the Australia government agency. They list some, they describe some opportunities for airport to use hydrogen. For example, they have the plan to use the hydrogen for the ground vehicles and ground support equipment by 2025. And airport they want to update the airport infrastructure and support hydrogen fly by 2035. Also, they want to they identify the opportunity to replace the traditional jet fuel by 2050. Those are, I think the government and the industry already realize that opportunity. So the airport they kind of a delay from the goal. And as we all know, so you may know already, the Australia government want to establish 7 hydrogen hubs around the country. And so they want to produce the hydrogen in the future at under $2 per gallon, per kilogram. So the current jet A fuel, the current price of jet A fuel is around $1 per kilogram. So if they can achieve that, $2 a kilogram, so that would be very attractive for the airline to use hydrogen if they if they consider the carbon tax in the future. Okay, so what are the let's talk about the research question and the methodologies. So the primary challenge, the research question is, what are the primary challenge for airport planning to enable the hydrogen power fly? And we review and investigate the available and existing available academic and industrial studies on the hydrogen infrastructure technology and the policies to that relate to support the hydrogen operation, and then define the requirement and the gap. Then we summarize this and present in under the typical structure of airport master plan, because if we want to achieve hydrogen operation at the airport, it's a long-term strategy. So the master plan probably the best document to reflect the goal. The purpose is to enhance the body of knowledge in the airport management and planning for hydrogen operation, and also we want to help the airport who are considered to use to support the hydrogen operation, and help them to speed up the process. Okay, through the analyze, we figure out the challenge will be in 4 big areas: airport land use plan, airside development plan, and utilities infrastructure, and development, and finally the safety, very obvious safety training and security. And the first one, airport land use plan, actually is related to the storage and produce hydrogen. So there are 3 ways to deliver the hydrogen to the airport. Use a truck or train or ship. Or another one is to use the pipeline. Finally, you can produce hydrogen at the airports. Regardless which way you want to use, you have to store the hydrogen at the airport, right? So first you have to for the smaller airport, they may not need a tank, because the largest tank we're using in the world right now is established is created by NASA. That's the largest one, which is the 20-meter diameter big. It's like a ball, and can hold 220 tons. So those that amount of hydrogen can support 200 short range fly, which means the regional flies. And for small or regional airport, one liquid hydrogen storage tank is pretty enough. And if the hydrogen arrive at the airport in a gaseous form, we have to use a liquefier to transfer the gas hydrogen into convert the gas hydrogen into liquid hydrogen. Hydrogen. Okay, then we can store it, or we can just to fuel aircraft. So the liquefier is definitely larger and require larger space than the tank, but it's aboard as 25 to 300 square meter per ton if you want to liquefy that amount of hydrogen. And finally, you may want to produce hydrogen on site. That's really depend on if you have the demand of hydrogen. It's really depend on the role of the airport. If you want to be a hydrogen hub, and then deliver the hydrogen to all around the to provide hydrogen to the region, provide the outer region, the whole region. You may want to produce hydrogen on site. And those hydrogen plants would be required 8,000 square meter of space. So for most of aircraft, even a major airport, say it's not necessary to produce hydrogen on site because it may not make a business case for them. And first they're gonna use the railroad transportation. And if the railroad transportation or the truck transportation gonna cause congestion on the traffic transportation, they may switch to pipeline. And pipeline probably already enough to meet the demand of aviation operations. However, the Australia have a lot of renewable energy, and so produce hydrogen on site may be a good choice for airport to uh, uh, hello, can you hear me? Yeah, I don't know why. Hello, should I continue? Oh, okay, good. So yeah, so I talk about it, yeah. So to produce hydrogen and on site is a really good opportunity for airport to enhance their non-aviation revenue. Okay, and but yeah, they have to make the plan. They have to make the plan maybe since right now, and they can achieve this maybe 20 years later. Okay, so the potential double terminal system, as we discussed before, the aircraft, hydrogen aircraft should be longer, will be longer and heavier, and also because of a physical characteristic of hydrogen, the hydrogen the refuel process for hydrogen aircraft will be longer than the traditional refuel process. And so the hydrogen aircraft will be need a longer turnaround time. And they also need a separate hydrate, which means the pipeline system to refuel the aircraft if they do need it in the future. And so there may be some conflict between the hydrogen aircraft and the traditional aircraft, and the airport may need to establish a double terminal system. That doesn't mean you need to build a new terminal. You may just update a part of the terminal and then only use it for hydrogen operation. Okay, so yeah, right here, the terminal we just talked about it is very we just talked about it, so we'll talk about it more. And right here, so in the picture, that's the picture from the Airbus, and they gave us 3 examples about the hydrogen aircraft. So the first one and the third one are we call the evolution aircraft, which is the upgrade, the update, the update the traditional design and to make it fit the hydrogen operation. But the middle and the second one, which in the middle, is the blend wing body. That means the wing, the length of the vane actually is longer than the traditional one and may need more room if they want to park at the gate. So that requires the update on maybe require the reconstruction of the terminal. I had mentioned a little bit about the refueling equipment, the new truck, and the new hydrant. Hydrant is the pipeline and from the ground. If you don't know, and so they can just directly refuel the store the fuel under the ground and through then connect to the aircraft to refuel the aircraft. And we also need the ground support equipment. For example, new support equipment like a touring truck, because the new aircraft will be heavier than the traditional one, and we may have to design a new touring truck as it right now, and then use in the future. Okay. The third one is the Utility Infrastructure Development Plan. As I discussed before, if you want to use hydrogen, it must be green hydrogen. Otherwise, it would be minimalized to use hydrogen. So the electricity used for hydrogen production needs to be from renewable energy. And it's a kind of advantage of the Australia because we have a lot of renewable energy, right? Like solar power, wind, and hydrogen production require a lot of high purity water, and so purity water have to create by renewable energy. So if you want to produce hydrogen on site, you have to figure out what type of how to meet the requirement. Okay. So the last area for the challenge is the safety, security, and training. And aircraft refueling, as we mentioned before, the fuel safety zone will need to be attended to 30 to 60-meter wide under the current standard. And for the jet fuel is only 8 meters right now. And so the according to the research I investigated, they estimated they can reduce the refueling fueling safety zone to 20 meters in the future for the hydrogen, but it's still doubled, even doubled than the current fuel safety zone, and it's gonna disturbs a lot of turnaround operation, such as the loading the luggage and passenger boarding. So they definitely need a longer turnaround time, and they need to define and establish the new regulation for refueling. Also, for the airport rescue and firefighting, it will be another area to update it, because hydrogen have a different physical characteristic, and so they need a new recruitment and training to deal with the new situation. And the airport should provide the appropriate training to the staff who are working around the hydrogen production area or the storage area. They need to able to recognize the potential risk. Okay, the employee training, the employee not not working on that area also need some training, maybe very simple training what just watch a radio. So they also have to have the ability to recognize the risk. And the policy framework and safety standard, that's the essential part of the operation. If you do not have if the hydrogen operation is not approved, or if there is no established standards, the hydrogen operation will not happen at the airport. So according to the hydrogen, the challenge we face, we create a roadmap of the timeline to help the airport to recognize the emergency of the emergency level to figure out to solve the problem. We can see the storage and the airport land use plan actually not very urgent, because in the first of operations, they can use the truck to refuel, to store and refuel aircraft. But as the demand of hydrogen increase and as the hydrogen operation increase, in between the 2025 and 2025 and 2035, they should think about it to build a storage and to build a storage tank and to establish a liquefied plant at the airport. However, they may, as I described, the produced hydrogen at the airport sometimes do not make sense to most of the airport. Most airports, if they want to produce aircraft, produce hydrogen, they have to work with the government and different airline, different organization to make them as a hydrogen hub in that region. So they can sell and sell the hydrogen and support the hydrogen applications around that region. And for the airside development plan, the refueling equipment definitely very urgent. If you cannot refuel the aircraft, how could you support the aircraft operation, right? So the terminal, in the short term, we don't have to upgrade the terminals, because I expect the aircraft, the hydrogen aircraft, the new hydrogen aircraft will be regional aircraft, which is the small aircraft. So the current facilities at the terminal are pretty enough for support to serve the regional aircraft. Okay, but the ground support equipment that.
I guess the
Okay.
internet is not good.
Okay, and for the utility instructor is highly related to the hydrogen production. If you do not produce the hydrogen on site, it won't be a problem. The most urgent challenge we are facing are the aircraft, are the safety, security, and the training. Those are the essential part of airport operation, and to support and make the hydrogen operation happen around the airport. Okay, let's talk about the key funding. The challenge on airport use land will likely depend on the scale of the demand for hydrogen, the location and the size of the airport. If as the demand of hydrogen increase, you definitely need a more storage liquefied plant, and in the future, you may consider to produce hydrogen on site. Airports that locate a region with abundant renewable energy resource have advantage in hydrogen production. As I just mentioned, you need a lot of electric power, that's created by renewable energy, renewable source to produce green hydrogen. And the Australia has that advantage. And the development of a regulation and procedure is an emergency since the hydrogen flight may become true in the next 5 years. So as I just mentioned, the regulation part probably is the most emergency things have to be and the challenge have to be overcome. Okay, and that's all I have today. And those are the reference I used. Do you have any questions and
Okay,
comment?
thank you. Thank you for Dr. Gu's presentation. And we're going to stop recording now and start our question sessions.